So again, I'm going to take my spatial fidget. So it's the one that's on my screen right here, the MOT 1101. And I'm going to plug it into my computer now. So again, I just have my same setup there. I had the Vin hub, and then I have the spatial, and I'm just going to connect this end, the USB end, to my computer. Okay. So once I have that connected, what I'm going to do, I'm just going to close these tabs out. I'm going to show where you would find the tutorial for this. So the idea is that once your students have completed the Getting Started kit, they have a basic understanding of fidgets. The next step from there is they would start looking at individual devices. So if we look at the Learn tab up here, we have the Getting Started kit. So this is another way that you can navigate to that course. And then you can see it's leveled. So that's level 1. Level 2 is the device tutorials. So this is where you would find information on specific devices like the spatial. So if I click into this, we can see a list of devices. So what I'm going to do, what a student would do, is they would look for their specific device in the list. So here I'm looking for the spatial sensor, and then I'll click through to that. And this will bring me to the tutorial page for the sensor. So here we have the spatial sensor page. Just like the Getting Started kit, it has information about what you're doing. It has a very similar format. So, you know, you're learning about the spatial fidget. It has an accelerometer, gyroscope, magnetometer. And if we scroll down, it's going to have that setup image. So this again is the exact same setup I have on my desk here. I have the Vin tub, I have the spatial, and I have the USB cable. And then if we look at this one has more sensors in the individual, like this, it has the 3 sensors built in. So the left-hand side navigation is going to be more important for this one, just so that we can keep organized. But if I just go down to this accelerometer section, this is where I'm going to get my code for the accelerometer. And then I'm going to basically, just to give everyone an example of what it looks like when it's running, I'm going to copy this code. So I'm using the copy button up here, or I could just highlight this and copy it in. Today I'm using Thonny with Python. So I'm not sure if anyone is familiar with Thonny, but it's just a development environment for Python. It's a really nice, easy environment. So I'm pasting the code in. It's going to prompt me to save the file. So I'm just going to save it as accelerometer.py. The name doesn't matter. And then I'm going to run the code just so we can get an idea of the output from the accelerometer. So I'm going to try to expand this so everyone can see. Okay, so here's my raw data from the accelerometer. So it's just sitting on my desk. And what I can see here is I have an X, a Y, and a Z output. So there's 3 axes for the accelerometer, X, Y, and Z. And if we take a look at the code more closely, we can see that it looks just like any other Phidget program. It has the import statements up here. So regardless of your programming language, you're always going to have this import statement at the top. So you're gonna import the Phidget libraries. And then in Python specifically, you have to import the specific device you're working with. So in this situation, we're working with the accelerometer. So we have to import the accelerometer. If we were importing, or sorry, if we were using a distance sensor, then you would do something like this. And you would import the distance sensor class. So these are all just classes. These are all Phidget classes, basically, that relate to a specific device. So that's all this top part is up here. This is, you know, for Phidget's code, there's only a few lines here. We have this first line here, which is actually creating the object. So again, we have this accelerometer class, and we're creating a new instance of it here. So I've called this accelerometer. You can call this Excel. You can call this X. You can call this Y, just a variable name. So we've just called that accelerometer for readability. And then the next step to any Phidget program, so no matter what device you're working with, is you're always going to be opening the device. So after I've created it, I want to call open, and all open does is it takes it's saying like, hey, I have this physical Phidget that's connected to my computer, and I have this software object that I've created in Python, and it just bridges the two. So that's all that call does, and you need that in order to use the device. And then after that, the main line of code here is right here. So I'm just going to take this out. I'll just make this, knock it down so it's easier to read. So if I just print that, so I'm saying accelerometer.get acceleration, that will give me the most recent acceleration value from this device. And because we have 3 axes for acceleration, I'm taking the x-axis, which is 0. So this is x, this would be y, and this would be z. So 0, 1, 2, it's an array of the axes. And again, this specific device is a slightly more advanced device than our other sensors. So for example, if you were working with a distance sensor or a temperature sensor, you wouldn't have arrays like this. The Spatial is a little bit more of an advanced sensor. So just something to keep in mind. If you're giving this to a student, you might want to hold off on giving it to, maybe give it to the students who are more advanced at first, just to so they can get a feel for it. And maybe they could help guide the other students, or just also give you an idea of what it looks like for them to understand it. So that's all this is doing. And then if I ran this, it would just print out the values from the accelerometer. And we're going to go through these more closely, just so that we have a better understanding of what's actually happening. But that's your basic code. And it's going to be the same for the gyroscope. We have, again, the gyroscope code, and we have the magnetometer code. So all of the codes there, so that you always have a code base for your students. And then after you get the code, for example, for the accelerometer, we have an application section, just like we do for every other device tutorials. So it gives them some information on what this device actually does. And then we also have some practice problems, so they can start kind of working with the device and getting a feel for it. We actually just recently added the Spatial and the accelerometer, which I'll talk about in a bit. So what we're going to do is we'll talk about what else they can do with this stuff. So that is where you would find the base code for this device. So if you have the Spatial, you want to go to that device tutorials page to find the code for it. One of the things I did want to talk about is the different types of spatial devices. So if everyone here, I'm not sure if anyone here has gone to phidgets.com. So this is our actual customer facing site. So if you're an engineer, this is where you would go to buy your products and everything like that. For students, they're always living on phidgets.com/education, which looks like this. And we were just on this. So this is the education site. So this is where students will live and get all of their content. But for some teachers who are looking for other devices, this is where you might want to be sometimes. And the reason for that is it just has all of the devices. So if you are looking for a specific device, you can find it here. So what I'm going to do is I'm going to go to sensors, and I'm going to go to motion, and that will just bring me to this this motion page, which will show us all of the spatial devices available. So there's a few that I want to talk about here. The ones specifically that are important to kind of know about and understand are the Accelerometer Phidget here. So this is basically the exact same thing as this Spatial. The only difference is that it only has the accelerometer. So it doesn't have the 2 other sensors, the gyroscope and the magnetometer, just the accelerometer. And you can actually do a lot with just the accelerometer. So it's a good option, and it's slightly cheaper. So that might be something to consider. This is the Spatial that we're talking about today. And then the only other device that you're going to want to potentially look at is this 1044. So I've listed all these here on this document. So these are kind of the main ones that you might want to use in education. And again, this presentation will be up for about a week. So if you do want to download it or reference it, this will be available at that bit.ly link. Okay, so the main differences between these devices, again, the accelerometer is strictly an accelerometer. So it also has a page on device tutorials. So if we go to device tutorials and we scroll down, we'll see this accelerometer here. So it also has its own page. It's its own sensor. So that's something that is a pretty nice sensor. The Spatial is the exact same thing. It just has the 3 sensors. So it has the accelerometer, the gyroscope, and the magnetometer. And then the 1044 is really just a more advanced spatial sensor. So it looks like this. It has an enclosure. Some of them come without the enclosure. So very similar looking device if you took out the enclosure. The only difference is this one plugs directly into USB. So it doesn't have the vid tub. And the main difference between this one is this is just a very, very high quality sensor. So it's much more expensive and it's extremely accurate and extremely sensitive. So this is what they used. I'll just kind of show you all something quickly. So if we navigate, I'm just going to the Getting Started Kit tutorial. There's a video component here. So if I go to this and just show you, this is actually what was used in. They basically had that 1044 in like 1,000+ different devices all across California, and they actually used this to measure earthquakes and see how they propagate across California. So like a super accurate, super sensitive device. But for the classroom, mostly the MOT 1101 and the MOT 1100. It's probably all you're going to need. So the next question is, okay, well, what do I actually do with these devices? How do I use them in a classroom? So we have shake detection, angle detection, or angle calculator, and orientation. So you can do a lot with just the basic accelerometer. So what I'm going to show you is what a shake detection piece of code would actually look like. So I have this program here, and what we're doing is we're going to be having these projects on the website in a few weeks. Again, the Spatial and the Accelerometer are brand new to the website, so we're still getting content for them, but these will be up fairly soon. So basically, if I run this program, so what it's doing, actually I'll clear this. So it's running the program and it's basically waiting for this thing to shake. So if I shake this, we can see that it prints shaking. So this is one kind of use case for your students, is like, okay, I want to see if this thing shakes, and if it shakes, I can do something else. So you could have some output that's dependent on the shaking, or if they have a game, like a lot of students are doing video games like Pi Game and things like that. They're using Unity, so that could be some kind of an input to their game. So again, all we're doing is we're doing the exact same thing we saw in the first program. So we are importing the accelerometer, we are creating it, we are opening it just like we do for every single program. And then what we're doing here, we have X, Y, and Z. So we've just kind of split it up here so that the code is a little bit more readable. So again, X is the 0, Y is 1, and Z is 2. So what we're doing is we have a little piece of code here that's just calculating the magnitude of the shaking. So there's a bunch of different ways you can do this. This is just a really common way because you basically have an X, a Y, and a Z. So you have kind of 3 vectors, and this is just getting the magnitude of those vectors. So this will end up with a value that gives you some indication of what's happening with the accelerometer. So if I printed this, just so that we can get an idea. So if I ran this with it printing, we can see that what we would expect is about 1. So we're getting about 1. And if I kind of shake this, it goes up to about 3 or 4. So, okay, if I shook that, a pretty hard shake was getting me to around 3. So then I'm using 3 as my value to compare to. And depending on what level you set that to, you can get like you're looking for a more aggressive shake or a less aggressive shake. So that's all I'm doing is I'm taking those, I'm calculating the magnitude, and I am printing out when it's shaking. That's one example of something you can do with the accelerometer. The other example that we had was the angle detection. So if I close out of this, I'll just open my angle detection file. So if I run this, so what I'm doing here is I'm calculating pitch and roll, but all I'm really doing is I'm just trying to calculate the angle of my spatial. So let's start with pitch. So I'm just gonna comment out the other one so it's easier to see. So if I run this, basically what this is doing is I'll do it this way so you can see. If I rotate my device, we're able to see the angle that it's rotating. So I just rotated it about 90 degrees. Then if I go back and go the other way, we can see it's about 90 degrees that way. So this is one very simple thing that you could do, but it's actually quite powerful, and you can do a lot of really cool things in your code as a student. Again, with their games, with their projects, they can use that as an input. And then the pitch is just calculating it on the other axis. So if I were to go this way, I'll show you actually quickly. So if I were to go, if I comment out the other one, it'll just do it on the different axis. So now if I'm going up and down like this, it will detect that angle. So I can go close to 90. and then I go close to 90 the other way. So a really kind of simple way for them to get some cool interaction to their code. And they also get to, experiment with some math. So again, this is going to be, it's not live just yet, but this is going to be a project on the website very soon. And we'll be sending out a reminder. We have a new newsletter coming out on the 15th. So it will have links in the newsletter to the new projects that are available. To show you a real example of that as well, back to this video that we had, there was an example here from someone who was doing an art installation. So this example here of the art installation. So he's using that same technique we just saw to input into this interactive art exhibit. So basically he had a spatial sensor on the back of his portrait, and as it was tilting, he fed that into his program. So it looks like a painting, but it was made in Unity, and then he was able to create that effect where things are falling over. So that would be like a kind of, another use case for it, which is kind of cool. And then just so that, again, that we all are on the same page, this is where you would find the project. So, once students have experimented with the device tutorials, so they have some code for the device, they know how to use it, the projects will be here for the spatial. So in about probably a week or two, you'll be able to scroll down here and find the projects that we're talking about. So there'll be a tilt angle calculation project, and there'll be a shake detection program for students to try out with a spatial. We start looking at things like the spatial devices. So now, instead of just using the accelerometer, we're looking at using the accelerometer, the gyroscope, and the magnetometer. So there's some really cool things you can do with the spatial when you have that available. This is a program that was written for the gyroscope. Basically, this is, again, it's an advanced program, but basically this allows me to measure rotation, kind of similar to what we just saw, but this is what you would see to kind of measure a heading. So I'm just rotating this and it's tracking that. And again, this is getting into math because the gyroscope is returning a value in degrees per second. So we are integrating that to get degrees. So I'm plugging in my 1044 now, and I'm just going to show you a program that actually uses this. Actually, it's going to be hard to see probably, but you can see in the top right, it's actually it's actually creating a model for this in 3D space. So that is what you would use all three sensors for. And that's what people would use it for. So, in a classroom, the accelerometer might be more than enough for you, but this is some stuff that is possible if you are going for the spatial route. And basically what we've had students do is I'm just going to unplug this. So that model that's created has an output called a quaternion, and they're able to feed that into things like Unity and control objects in Unity just by kind of holding it. But I guess the main thing to kind of get across is that if you're just looking for some basic motion and basic math, things like that, the accelerometer is a really nice sensor. It's quite cheap, especially with the educator discount. I believe it's only around $10, and you can do a lot of really cool stuff with it. And the spatial is really, I would only kind of recommend the spatial if you are looking to go to that next level, or you have a student who's really looking to go to the next level, because it is going to take more of an understanding of code and math to actually get something out of it.